Okay, let's move on to operations on vectors. So we have three basic operations listed on page 348, addition, subtraction, and also multiplication. So let's see how how to apply these. Let's look at an example. Let's look at number 32. So 32 gives us a pair of vectors, u and v, and we have to perform these four operations, which shows addition, subtraction, multiplication with addition, and multiplication with subtraction. So let's start with with A. So A, we have u plus v, and u equals -3 and -4. V equals 0, 5. So to get u plus v, we're going to add the horizontal components. So that's -3 plus 0, and add the vertical components. So -4 plus 5. So we're just adding the components. So -4 plus 5 gives me, so I get, let's see, -3, 1. I can call that R for resultant. I'm not sure how to spell that. And graphically, what that looks like is we start, so we're doing u plus v. So we start with the u, so draw in u as a position vector. So that starts at the origin, and then you go to -3, -4, 1, 2, 3, 1, 2, 3, 4. So this, hang on a second. 1, 2, 3, 4. My tablet does not like this corner. Okay. 1, 2, 3, 4. There we go. So that is u. And then to add v, we start where u ended. So we're going to add on to u. So starting at the end of u, or the terminal end of u, is the initial point of v. So starting there, we go, v is horizontal component of 0, so no movement left and right, and a vertical component of +5, so we go up 5. So 1, 2, 3, 4, 5 puts us right here. So this is v. So our result, I'm going to do our result in green. Actually, I'll do a straight line in green. Starts at where u started and where v ended. That is R, or the result, which is u plus v. So we start at drawing u as position, and then starting at the terminal end of u, we start v. All right, so that's addition. Now let's move on to subtraction. So that's B. I'll do that one in purple. Okay, so B, similar, but we're going to do u minus v this time. So our u and v is the same. U is -3, -4, and v is 0 and 5. So our u plus v, let's look at two u's. I'll take -3 minus 0. So -3 minus 0, and -4 minus 5. -4 minus 5. So using this formula now. And when I simplify that, I get -3, -9. That I can call that R again for resultant. And again, graphically, we have start again with u. So u is the same as before, which is -3, 1, 2, 3, and then -4, 1, 2, 3, 4. So it starts at the origin, and the terminal side is at -3, -4. And then we start v where u ended, but this sign we're subtracting, so you can also think that as negative v. So I'm going to go down instead of up. So if v is 0, 5, that means negative v so negative v equals negative 0, which is just 0, and negative 5. So I'm going to go down instead of up. So 1, 2, 3, 4, 5. Not as straight. Not liking that either. Let's do a straight line tool. There we go. So we have, this is u, and this one's negative v or minus v. And that result, I will do in green again. So I start where u started and end where v ended. I'm going to do a straight line tool. Okay, so that one, this guy, this vector, that green line is a vector called r, which is a resultant vector, which is u minus v. And I think I have a little typo there. That should be minus, not plus. And you'll notice that the vector, the resultant vectors is that green vector. So hang on, let me get that green pen again. So my resultant vector, when I did it algebraically, was negative 3, 1. But you'll notice that this green line is also, it ends at negative 3, 1. So that is this what we got algebraically and graphically, we get the same vector as the resultant. Same with subtraction. The resultant vector is negative 3, negative 9. And if you look at the green line, that starts at the origin and ends at negative 3, 9. That is the negative 3, negative 9, sorry, is that resultant vector. All right, let's move on to C and D. So with C, I have to do some multiplication first before I do the addition. So I need to find that vector 2u, and I need to find the vector 1.5v. So for C, I still have the vector u is equal to negative 3, negative 4. Hang on, let me get let's see. Negative 3, negative 4. And v is 0, 5. I'm still working with those two vectors. But for part C, I'm looking for 2u plus 1.5v. So I'm looking for 2u plus 1.5v. So to find that, first I have to find the 2u. So 2u, that follows this formula right here, where we just multiply each component by that scalar. Okay, so in this case, that k is 2. So 2 times negative 3 gives me a negative 6, and 2 times negative 4 gives me a negative 8. So I'm taking this thing and multiplying it by 2. And I need 1.5v. So this is v. I got to multiply each piece by 1.5. So 0 times 1.5 is 0. And 5 times 1.5 is 7.5. That's 1 full 5 and then half a 5. And then when I add those two together, I'm adding those components, negative 6 and 0. So I'm going to do some highlighting here. To get the y component, I get negative 6 and 0. And I get negative 6, and then my horizontal component is the negative 8 plus 7.5, which gives me a negative 0.5. So algebraically, this is what I get for my resultant vector. So let's see what happens when I try to do it graphically. So 2u means 2u. So I can draw in 1u as -4. So it's 1, 2, 3, 1, 2, 3, 4. So here's 1u. Oops, I need that guy. So here's a u, but I want 2u. So I got to do that again, starting where I left off. I'll do 1, 2, 3, 1, 2, 3, 4. So drawing in another u makes u twice as long. So that long purple line is 2u's, or 2u. And then v is 0, 5, or 1.5v is this. So I can go 0, 7.5, or 1, 2, 3, 4, 5. Recognize that's v. And then half of v is going to be 2.5. So that's 1, 2.5. That ends right there. So here's my v, and here's my half v. So that's 1.5 v's. So that's 2u plus 1.5 v's. Ends right here, and I'll use that green line for the resultant again. So it ends right here. Starts at the origin. And that's my result vector, which is -6, -0.5. So algebraically, we get this, and graphically, we get this, and they represent the same thing. Okay, let's do one more. So D was, I forgot what D was, U minus 2V. So I'll get a blue pen for that one. D is U minus 2V. So I still have the same U and V. So U equals -3, -4 with the vector brackets. And 2V, I'm using that same V, this guy right here. So 2 times that would be 0 times 2 is 0, and 5 times 2 is 10. So that's 2V. And I want to subtract them. So when I say U minus 2V, I take the -3 minus 0, and I get -3. I do -4 minus 10, and I get -14. So that should be my resultant vector. And that will look the same graphically. Give me the same answer graphically. So U minus 2V, so U is that -3, -4. So 1, 2, 3, 1, 2, 3, 4. That's our U. And then minus 2V. So V goes up 5, but we want to do it twice. And we want to do minus, so we want to go in the opposite direction. So if V goes up, we want to go down. So 1V is 1, 2, 3, 4, 5. That's 1V. And we want 2V, so that's another one. 1, 2, 3, 4, 5. And our resultant is, I'm going to get a straight line tool for this long one, from the origin all the way to where I end up. So that looks like the same answer as I got algebraically. I end up at -3, -14, 1, 2, 3, and then counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So again, algebraically, we get this, and graphically, we get that image, but they represent the same vector. So that is my solution for number 32. Got the solution a couple different places here. So there's the algebraic solutions and the graphical solution, which is the green lines.